Well, everyone, welcome to the AFuzion and Solid Sand monthly webinar. This one with our friends and partners Solid Sands there in Netherlands. This webinar is titled Safe and Secure Use of the Standard C Library. Really important to everybody who develops safety software, or pretty much any software, to be honest. Marcel, let's do a microphone check. We did one 10 minutes ago. Let's go ahead and check it again.
Hello, Vince. Thanks for doing this with me. It's always great fun. Can you hear me?
Fantastic. I hear you perfect. Like you're right next door, which you almost are. I'm over in Italy. I presume, Marcel, you're over in the Netherlands. Amsterdam. Beautiful. Well, folks, good morning, good afternoon. Let's rock and roll, as we say in Amsterdam, Rome, Italy, and many, many other cities throughout the world where you all are. Okay. This is a fun webinar, very fast-paced and very important. Some of our webinars are more esoteric, more general. This one is very specific, very dedicated. And again, thanks for tuning in, one of our monthly technical webinar series. So with that, let's rock and roll. A real quick note about us, Marcel and I, our companies. AFuzion is a big, small company. We've got 55, well, a little more than that now. We've been growing, but we work on-site, off-site throughout the world. We've got several engineers working full-time here in Italy, where I am today. But we do process optimization, all aviation. Aviation is almost always safety critical. We have templates, checklists, 178254, mentoring, training, a lot of certification, and frankly, a lot of systems, software, hardware, safety work. We work remotely, virtual, all the good things. Solid Sands, and Marcel is going to tell you a little bit more. Marcel, would you like to tell a little bit about your company? Well, Marcel, you probably all know Solid Sands. They're a world leader in C, C++ compiler, and library testing. They're based in Amsterdam, the Netherlands, and have over 10 people. They have SuperTest. It's a test suite with more than 35-year track record of really making safety critical systems safer and better. SuperGuard is a requirements-based test suite for the standard C library. So folks, when you want to know about the standard C library, yeah, it's Solid Sands and Marcel, the Chief Technical Officer here, who does all this great stuff. First, let's have a little bit of fun. Well, oh, come on, you're already having fun. Let's have a little more fun. A quick quiz, 5 questions. Now, we're going to answer these questions in just 40 minutes when we're done with this. But see if you can get all the answers right. True or false? Compiler libraries are not that important, and you can easily use any of them. I think you know the answer to that one. Buying a good compiler means you can trust it. Number 3, safety critical standards focus on application development, ignoring libraries. Oh, that's an interesting question. Number 4, compiler libraries are created equal. And number 5, if you were a hacker, you'd ignore the libraries. That's a subjective and very interesting question. Let's answer those, but first, let's dive in, shall we? What's a safety critical system really? It's a system, slide 4 here, whose failure or malfunction could result in one or more of the following: death or serious injury to people, loss or severe damage to equipment property, environmental harm, okay? Increasingly, everybody, and you're tuned in because you know this, but increasingly, most software, most systems, everything's interconnected. They have a contribution to safety. You all know that your car, your medical device, nuclear power plant, aircraft, they are safety critical. But industrial control is often safety critical. But what about these consumer devices? This is my smartphone. This is not a safety critical device, right? Well, wait. I keep my Bitcoin records, my Instagram, yeah. Wait. Oh my goodness, I smell smoke. Help, fire. Ooh, it just became a safety critical device. Can I trust my compiler and library? Ooh. Well, the answer, who do we trust in safety critical? No one. So, what are typical system components? Well, think of a system, and different domains, different industries use different definitions, but for us, a system is a standalone, separately powered device, okay? It has connectors, might have sensors, it's probably embedded. It has firmware in the form of programmable logic devices, application-specific integrated circuits, FPGAs, and we might use the standard C library on these, that's right. Increasingly, we have system on a chip, okay? Running netlists, IP cores, C software. But we also have CPUs, DSPs, microcontrollers. Here we definitely have board support package, BIOS, operating system, RTOS, libraries. This is our focus today, and you all know about application software drivers, our other training videos that you can find on YouTube, but this one's crucial. It's at the core, it's the library. These things are all safety critical. The hardware is safety critical. So let's look. This is the optimal route. We're going to focus here on software development. Yeah, the development environment. That includes the compiler and libraries. But before we get there, we have a safety assessment, requirements. We have a quality assurance group that's assessing, maybe we have system requirements. We have some plans for automobiles, aircraft, medical devices. We're going to trace to make sure that we cover those requirements with tests, have good configuration management. We're going to audit before we start building. Then we're going to have software requirements. That's going to tell us, yeah, which libraries we're going to need, what kind of functionality we're going to have to deliver. This webinar is not about the end item testing, the actual coding, integration, design, conforming. This webinar is hardcore focused on the development environment, primarily libraries, okay? Now, often overlooked is that compiler library. Oh, it came from the compiler manufacturer. I can trust it, right? Well, what is a library, especially a compiler library? Well, most of you are software developers. That's why you're tuned in. They're simply software functions that are used at compilation statically, at source code, by the compiler to extend, add, augment basic program functionality, okay? And we have a funny say, a safety critical program is only as safe as its compiler libraries, okay? That's a wiser old programmer, okay? So Marcel's gonna take control of the screen at this time, and Marcel's gonna be presenting for the next 25 minutes. Now, Marcel is the Chief Technical Officer at the company many of you know, Solid Sands. Very solid in compilers. If there's something that isn't known about compilers, well, it's not in Marcel's hands. They know everything about compilers. Marcel, it's all yours. Take it over.
Thank you, Vance. That's quite an introduction. I hope I can live up to that. Yeah, we are a small company. We're based in Amsterdam, the Netherlands, but we have our customers worldwide. So we deliver all over the world. And the reason is that we have a unique combination of qualities. And one is that we have this understanding of C and the C++ implementation. But on the other hand, we also have a deep understanding of safety critical software and the the protocols, the standards that are behind that, how to qualify library and software, and in particular the C and C++ implementation. So let me tell you a little bit more about that. So yeah, C library qualification, that's my main topic. That's what I'm going to show, the examples as well. Ask me about C++ later. I don't have time to go into that because yeah, C++ is yet another level up. But the reason you want to qualify your C library is that this library is going into your safety critical device. It's linked to the application. You wrote your application software, but that application software relies on the library to do the right things. And clearly, if there's something wrong in the library, that is a safety and security risk. Now, that's not the only reason you want to do this. The reason you want to do is that you want to do qualification is because it is also smart to do that. It's not just because you have to do it for the safety critical software, but also because you want to know that your software is going to run for a long time in that embedded device, and you don't want things to go wrong down the line. You know, the further you go in your development, if you find a defect, it's going to be more costly to fix it. Now, where do the standard C library implementations come from? If you're developing your implementation, very often it comes from your with your compiler. It comes from your software development kit. So yeah, you build your project, and the project automatically links to that library. So the library, as Vance already hinted, is it's a bit hidden in this process. You don't really see what's going on there. You don't see the code of the library. You don't see much of it. Of course, you include the headers, but in that case, yeah, the library is behind the scenes, and it's hard to understand. Yeah, there is really a big piece of software there that you need to do something about. Now, you can also get third-party libraries, maybe pre-certified libraries. Then you don't have to qualify them yourself, but you have to be very careful whether or not they are qualified for the precise use case that you are using them for. There's often caveats there, there's mitigations, there's a safety manual probably, and that tells you, okay, these are the limits of how you can use your pre-certified library. If you cannot work within those limits, then maybe it's necessary to do your own qualification. You can also get your library from a third party. That could be a vendor that supplies it to you, but it could also be open source. There's nothing against qualification of open source software. The procedures, the ISO functional safety standards, they deal perfectly well with open source as well. And some people prefer to write their own libraries because they're not sure what's in that code. They want to have full control. And then maybe you don't want to do everything, but you may even get an open source library, but some specific functions that are maybe specific to your application or hardware environment, you want to do your own. That's all possible, but you have to make sure that this is qualified well. Now, the way to do that is to base your qualification on requirements-based testing. And I like the V model because that really shows how the design of the system, as in the green dot picture that Vance already showed, the design of the system relates to the validation and the testing of the system. The V model shows that on the left side, left is here, on the left side, we have our development of the requirements, of the goals, and actually the implementation at the bottom level. And on the right side, at every level, we have test and verification. And those tests and verifications, they provide evidence that you implemented the right thing. There's no such thing as proof in software development, but functional safety standards, they stress that you have to follow this process of verifying everything that you do and at the right level that you do it. Now, diving a little bit deeper into the C library, the C library is defined by the ISO C standard, and we're very lucky to have a good ISO standard for the C programming language. There are not so many programming languages that have ISO specifications. Very popular languages like Python and Perl and many other languages, they don't have independently defined standards. There are probably good people behind that, there's a community behind that, but these standards are not approved by a standardization committee according to the same rigor that the ISO applies. So for ISO, yeah, for C and C++, we have this standard, and that's a very good thing. But that standard is not necessarily a list of requirements, and we're going to take a look at that in a moment. Those requirements have to be derived from the standards, and from the requirements, we can then make the link to the other side of the V model to our test specifications that define how we're going to test particular properties, and then writing the tests themselves, the requirement-based tests. Now, if you're working in safety critical software, then you also have to dive a little bit deeper. I'm not going to talk about that, but you have to look at code coverage as well, MCDC coverage, or as I should pronounce it, MCDC coverage, if I follow the real rules of that. That is a bit lower level. That's almost at the level of unit test, because then you're looking at the coverage of your source code of your library. But of course, out of all of this comes a requirements and test report. So the requirements are listed in a report. All the processes are listed in a report, and those reports can be certified by by an independent assessor of the process. Okay, diving a little bit into these requirements. What are requirements? Now, as I said, we have the requirements because we have the C standard. This is a picture from one of the books that was actually published. That was the C99 standard, was actually published as a book, which was a very nice thing. Very nice. I've got it here on the bookshelf. But these days, of course, we all look at the PDFs. But on the shields on the left side, right side of the picture, they show, okay, we have many versions of the C standards, C90 up to C18. We have even more standards, versions of the C++ standards. And when you are qualifying the library, you do that for a particular version of the standard. Now, if we look into the book, and we find here the definition of the specification for the strncopy function. So this is all the text that there is for the strncopy function. And it has been exactly like this since C19, and it's still like this in C99. I think the footnote was added at some point. But if we look at this really carefully and we try to figure out, okay, where are the requirements? That's not so easy. And actually, it's a bit strange how this is specified, because if we look at this, it says in the first sentence, the strncopy function copies not more than n characters. And then there's a sentence between the parentheses, and it says some characters are not copied. So you expect this to say somewhere it's copying this stuff, but it never does that. It never says you have to copy this and that. It only says what it's not copying. So that's a very weird specification. And if you think about this, it's actually written by a programmer, and the programmer wrote a while loop, and in the programmer's head there were two conditions in the while loop, and one of them was that there was a limit of n, and the other was that the null character would end the while loop, and that turned into this sentence. But it's a very weird specification if you look at it like that, and that there's some kind of assumption of eagerness. You're supposed to think, okay, this strncopy function wants to copy things, but not more than it's allowed to. Now, that's a very weird thing, because this is like a contract. This is a contract between the programmer and the implementation of the language, and you have to be very strict with these contracts. If supposedly there was a Dutch company called Tulips in Space, and they thought, okay, rockets are going to be big in space, and we're going to extend our market to the space, so we want to bring these Dutch tulips there, and they have asked for a rocket, and they want to have a rocket, and we are thinking of providing a bid for that rocket, but of course we don't do rockets. So we've named this thing Ponderous Lifter. We thought it would be a nice name, but I really can't tell whether it's going to lift any tulips or not. So what we put into that bid was, well, we're going to lift no more than 500 metric tons. And well, it's going to be interesting, see if they accept this specification of the rocket. So back to the C standards. The C standard, so we can conclude, is not a list of requirements. We really have to parse this text that we have here, and from that we have to derive and write down the requirements which are there. And nobody gets confused about the meaning of the strncopy function, but the requirements really have to be written down nicely. Now, there's one more thing that sort of a side note about the C library specification. And okay, I'm criticizing the standard here a bit. As I said, we are very lucky to have a very good standard. So this is just fine tuning, and I want this thing to be perfect. It's not yet perfect, but okay, that's a big thing. Undefined behavior in the C standard, it's a dangerous thing, of course, and you have to be very careful here. And yeah, I'm a little bit disappointed that we have to really look for the undefined behavior, because first of all, well, here it has a sentence that says, okay, this is undefined behavior, which is right, but that's not the only undefined behavior there. And really what these functions should have are a list of preconditions. So these are the preconditions for the function. So for example, it should say that these pointers S1 and S2, they both point to an array. Now that is in there, it's in the sentences that are pointing to the array, but these are really preconditions for the programmer. So they're not, yeah, they are part of the specification, but it would be nice to have those undefined behaviors. When does the function not do what it's supposed to do? Well, if you violate the preconditions. But the C standard and many other standards are not defined like this, and that is, in a way, it's a pity, and I really think that is a point where the standard could be improved. Yeah, here we have the other two cases, the array pointed to by S1. So these are really preconditions, but they're all in the same sentence. They're all at the same place. So what we derive from this text are these 6 requirements. Though the first 2 in green, they're actually directly from the test. So the text, so the bottom sentence, the bottom paragraph, and the return statement, they are nice requirements. They can really be turned directly into a requirement. But this big paragraph, which was a bit fuzzy, that paragraph, we have turned into 2 requirements, and one deals with strings that are shorter than n, and the other deals with arrays that do not have string length less than n. And those are 2 different requirements, 2 different cases, and they can be tested separately. Now, the bottom 2 requirements, they are not really in the standard at all, and they don't have to be, because the standard doesn't write down everything that is not supposed to happen. The standard only describes the behavior that has to happen. But it does not write that the string copy function should not rewrite any characters beyond the nth character. Now, that's obvious that it should not do that, but that is something that you can get wrong very easily in an implementation. So as a C programmer, we think about how to implement this function, and we know that dealing with n or n plus 1 or n minus 1, that is something critical, and that is really something that can go wrong, and we know that it can go wrong. So we put in there an explicit requirement that says, okay, this function shall not write beyond the nth character in the target array. And similarly, we also write down that the origin array should not be modified, shall not be modified. So those are 2 additional requirements, and we believe they are important to have a test for those, because those are things that can go wrong in implementations of the library. Now, what we get in the end, all this work we have already done for the C standard, of course. All this work together leads to a report, and that report, you can generate it in the form of CSV, just a spreadsheet-like model. This is a more textual thing, and here we see the requirement traceability. So this defines this horizontal line in the V model from the standard itself. So here we say that this has to do with the text from the C90 standard, paragraph 7.11.2.4. It's named the string copy function, so that is where this test and requirement comes from. It then specifies a unique requirement label, so we work with unique requirement labels in our implementation of our test suite. And then we have the text of the requirement itself, so really we can see what it says here. We are not copying the standard itself, because you can have that as a reference next to it, the PDF you can have open. So it's very easy to verify that what it says here covers everything that is written in the standard as well. And then we have derived from the requirement, we have the test specification over here. So this writes down, okay, the requirement describes what we have to verify, and the test specification describes how we have to verify that. And then, that's basically for the string copy function. We give it some inputs, and we have to give it a number of reasonable inputs. So taking into account this requirement, we have to give a string in there. We can choose long strings, short strings, 0 length strings. That's a special case. So you have to describe your boundary values for the inputs as well. Test specifications are usually not very complicated, but you want everything to be clearly written down, and from this it is easy to derive the test that is going to be written. And then finally, in a report, you will get also a stamp from the software that says, okay, your software is okay and you have passed the test. Now, obviously, for every requirement, you have to do it. For every requirement, you have to write test specifications. Sometimes a requirement is too big for a single test, and then you can have actually multiple test specifications, each dealing with one specific case in the requirement. So how to derive these test cases? This is from the ISO 26262 functional safety standard. ISO 26262 standard is a very nice standard to work with because it very clearly describes the process of qualification of the software. And this describes in this table a number of methods to derive test cases for the software that you're verifying. So the first one is obviously the analysis of the requirements. So you're looking at the requirements. First, you need to have them, of course. And from that, you can derive what the test is going to look like. The second and third have to do with the value domain. In our case, the value domain of the functions of the library, where you look at first as, what are representative values? So you define then your equivalence classes. Suppose you have a floating point function. You're not going to try that out with every single floating point number. You can do that when you have 32-bit floating points, but for 64-bit floating point, that's going to be a bit too much. So you choose in that domain of floating point values, you choose representative equivalence classes. And for those, you define a number of values that you're going to verify. And then you look at your boundary values for floating point functions. You would look at 0, negative values, positive values, infinity, not the numbers, values that are very small. So those are not the underflow, but the very, very small floating point numbers there, where you have special rules for the mantissa and the exponent of the floating point. They all fall in different classes, and you want to have representative values for all of them. And then finally, you also have, as a test implementer, you have to use your brain. So you use your brain in terms of the knowledge and the experience that you have. What could go wrong? And this is where our last two requirements come from. They're not written down in the standard, but clearly you have to be very careful with crossing the boundary of n for a string copy function. So all of these are input for deriving test cases, and we typically use all of these different methods to do that. Small thing about structural code coverage. Structural code coverage is required usually for the higher safety levels, of course, but it's not always possible, because if you get your library included with your compiler, it's probably pre-compiled, and then you don't have the source code of the library. So if you have that case, then it's going to be very difficult to do source code coverage, and it's going to be very difficult to use that library that came with your SDK and with your compiler for safety critical, highly safety critical applications. MCDC analysis is very useful. MCDC analysis is not just structural code coverage, where all of the lines of the code, source code, have to be covered. And we're talking about the lines in the implementation of the library in this case. But we also look in MCDC analysis at the branches and the branch combinations, whether all of the cases for those are handled. And that forces you to both of these, line code coverage and also branch code coverage. It forces you actually to take a look at that code. Is every line of code there, is it handled, is it verified by your test suite? And obviously when you find a case where the test suite doesn't touch your code, you don't want that to go into the safety critical device untested, so then you would add a test. But it also helps for security, because if you find a case where your test case cannot reach, then that might be something that really doesn't really belong there. So you can imagine in public domain code, someone tries to inject something, or someone has built in a backdoor with a special password, a one-time password, that is not going to be covered by your test suite. And then code coverage may alert you to this case over there that tells you, okay, you haven't covered this, but take a look at this code. This is really not code that should be there. So structured code coverage can be very useful for security. Oh, we got mail. That's from Tulips in Space. Let's see what they write. We got a deal. They shall pay us not more than $10 billion. Okay, I know where that came from. Friends, that was the end of my story. Let's go back to you.
Marcel, that was terrific. Thank you very, very much. Folks, have great information from Marcel and Solid Sands there. I see we have some questions starting to come in. If you have additional questions, anything technical here, especially at Marcel or I can answer, certainly on the C library, now's a good time to answer. We have a few minutes, we can dive into those, okay? So, before we do though, we have that little quiz. Yeah, it was half an hour ago we presented those 5 questions, okay? Let's go ahead and look at the answers, okay? Question number 1, yeah. Are compiler libraries important? Well, you know they are, okay? So, very, very much so. In fact, yeah, they're mandatory. They're at the essence of safety critical systems or any system that uses the standard C library. Now, you, in theory, can use any library, but you all speak English. You know that any sentence that begins with the word in theory is suspect. In practice, you have to show that it's safe. If you don't know the pedigree, if you can't analyze, if you cannot test that C library, how do you know it's safe? Well, if you're making a safety critical system, the answer is you can't. So truly, compiler libraries really are important, and you have to show that you got it. You can easily use them safely. You have to know what they do. Question number 2, buying a good compiler means you can trust it. Well, all compilers are good. They compile. That's why they're called compilers, but they're not great, okay? Think about this. Is any compiler provably correct for all possible input conditions? Well, the answer is no. Because how many input conditions are there to a compiler? The answer is infinite. The same as the number of songs in the universe, okay? So, no, you cannot trust it. Question number 3 is interesting. We hate to give you that yellow light. Now, sometimes I'm back at my home in California. Right now, I'm in Italy. Italy and California are similar in how they treat yellow lights. Yellow light means go, don't stop. If you stop for a yellow light, your car's gonna be short. Yeah, you're gonna get hit from behind. Well, in some countries like Australia, I was just there working last week, in fact, and Australia, yellow means stop. Yeah, don't enter. Well, yellow here means warning, danger. Safety critical standards, well, they focus on application development, but they don't ignore libraries explicitly. Unfortunately, most safety critical standards do not have special treatment of libraries. For example, you saw that page 3 slides ago that Marcel showed us. Remember that one? Oh yeah, this one, ASIL, yeah, automotive safety integrity level, you got it. Well, folks, level A, B, C, D is the opposite in aviation, okay? What do these say about libraries explicitly? What does DO 178? Medical standards, nuclear power, ooh, yeah, okay, you got it. Well, folks, we cannot ignore the library. We have to quantify, show that it's safe, requirements. Yeah, Solid Sands has the answer for that. Number 4, compiler libraries are created equal. No, folks, I'm not created equal. I wish I had great athletic skill and could dunk a basketball. We're not created equal. Maybe we have equal rights. equal rights to the pursuit of happiness, right? But we're not created equal. Either are compiler libraries, not at all. And number 5, if you were a hacker, you'd ignore the libraries? Folks, if I was a hacker, that's the first thing I'd hack. Why? Think about this. I don't have as clean of access to your source code base, your application, okay? The libraries can be hacked. They're not typically a monolithic executable, okay? I have access to them. Usually the user doesn't have the intimate knowledge of my libraries like they do of their own application software. The libraries give me access to many aspects of my RTOS, my port support package, my hardware, okay? And they're not checked. The libraries are the first things I'd look at if I were a hacker. And in fact, many of you are operating under a cybersecurity standard or threats. If you're in aviation, you know what DO326 or ED202 means. Those are the cybersecurity. That's malware. That's intentional hacking. That's not a design defect. That's a human or maybe an AI bot that is intentionally trying to hack our software. Okay, so no. I'd focus on the libraries. You would too. Okay, folks, you made it. That's our webinar for today. If you want some more information, we've got a couple real cool QR codes. Pop out your phone, download these white papers, just send in the request and you'll have them by tomorrow. Top software mistakes from AFuzion or qualifying the C standard library from Solid SANS. And I think we've got some questions here. So one question asks, will we make the recording available? You bet. We always put the recording on these AFuzion webinars up on YouTube. So just Google the AFuzion channel. That's with a Z, AFUZ, and you'll see quite a few free videos up there. And can we elaborate more? Ooh, I think, Marcel, you're going to like this one. Can you elaborate more on how does not having the source code of your C++ library affect the safety certification? I'm confused. If I bought a library, wasn't that supposed to be certified? Okay. Marcel,
Yeah, well,
you want
to? Can you hear me?
Yes, absolutely.
Yeah, that depends, of course, how you get that software. So there are libraries and software development kits that do come with a certificate. And as I said, those are pre-certified libraries and compilers. But you have to be very careful about what they are certified for. So there may be limits on how you can use that. But in principle, yes, it is possible that you can get pre-qualified library. But there are not so many around. I think ARM supplies some pre-qualified libraries, for example. Now ARM is of course used everywhere, the ARM processor, but there are many other types of processors used. And for those other processors, it's often not so easy to find a qualified implementation, a qualified compiler and a qualified library. So this is not always available, and if they are available, they might not even meet your requirements. So it's certainly good to know about this issue, and we hopefully can then provide a solution for you and work with you to get your library qualified.
Very good, thanks, Marcel. And we have the question, would libraries be covered by qualification standards like DO330? That's a great question. Folks, if you're in the aviation business, you know what DO330 is. If you're not, well, we'll explain. In fact, many of you are in the automotive realm. Automotive uses ISO 26262, International Standards Organizations. Now, guess what? IEC 61508 is the parent to 26262. Where was IEC 61508 largely copied from? It was DO178, and that's okay. We copy back from them. We copy a lot from each other, okay? These standards committees. Now, DO330 is actually a tool qualification supplement to DO178C and DO2788, okay? Libraries are not tools. Tools are software that doesn't fly. An operating system is a great tool, except it's not a tool. Operating systems fly. Libraries fly. Tools are for software programs that don't fly, like a compiler, a linker. Oh, the actual compilation engine is a tool. The linker is a tool. The library actually flies. A code generator is a tool. The output of the code generator is code. That's why it's called a code generator. You knew that. Well, that flies, okay? If it flies, it's 178. If it's aviation on the ground or automotive, it's DO 278 or ISO 262. But these are, yeah, DO 330 is not for libraries. DO 178C is for the libraries, okay? Interesting. And we have a question. Does companies like Solid Sands, do they do certification of libraries? Ooh, I'm going to let Marcel answer that one. Marcel, you folks, Solid Sands, yeah.
Well, no. What we do in principle is the qualification of the software. That's the thing that we're good at. So the technical work, the whole process of the qualification, and then to get things certified, you need to go to an assessor, and that can be well, the TÜVs in Germany. They're very well known for doing this kind of job, because these two things are really separate activities. First, the qualification itself. That's a process that you follow, that's described, and you have to do that according to the requirements of the functional safety standards, DO 178 or ISO 26262. That process gets recorded, gets written down, the results can get written down. You probably need some mitigations in there as well, because you will find errors. We will always find errors in compilers, for example, and the same is true for libraries as well. So you get some known errors, and you need to provide mitigations for that. Now that whole process gets wrapped up, and that goes to the assessor, and those documents are then certified. And that means the assessor puts a stamp on it, and they say, okay, we can see that this process was followed according to the standard. And that is then your certification. It certifies that the process was followed in the right way, and that every requirement in the functional safety standard is correctly implemented. And so that's the difference between qualification and certification. And of course, yeah, if you want us to do the certification, then we would go to a third party to make sure they put the certificate stamp on it.
Excellent, Marcel. Very good. And we have a question in aviation, avionics. What's required to certify a compiler library? And if it was already certified on one avionics application, would I have to recertify it? Ooh, that's a great question. Well, what's required for DO 178? It's related to the answer I provided 2 questions ago for tools. Compilers are tools. Compiler libraries, their output, if it flies on the aircraft, is not a tool, it's the actual software. So DO 178 or ED12 in Europe, it's called, it's the same document, okay, in English. But there's 71 objectives for level A. Look at my fingers, okay, 10 fingers. I need 10 categories of information. I need plans, 5 plans, 3 standards. I need requirements, review of requirements, design, code integration. I need test, review of tests. I need, configuration management, quality assurance, and certification. Those are the 10 categories, not 9, not 11, there's 10. Those are the 10 tables in the back of DO 178. Across those 10 categories, there's 71 objectives. Compilers, as Marcel says, they fly. They are software. So there's 71 objectives for level A, 69 for level B, 62 level C, and level D, you don't have to. You don't need them. Level D doesn't look at the compiler, the libraries, or the code. So you just need, high-level requirements. You're done, okay? But it depends on the DAL, the assurance level, A, B, C, how much work you have. But folks, great question. If you already certified it, and you don't change that library, you don't change the compiler, you don't change the processor, okay? What do you need to do to recertify? Well, only two things. There's not 71 objectives, there's only two. You have to retest it and review the test. Show you used it correctly. Show you didn't break anything. Okay, that's the answer. Marcel, looks like the, yep, go ahead, please.
Yeah, so what we find is that for the use case, so the configuration, the compiler is much more sensitive because yeah, even if you change an option in the compiler, so you run it with -01 or -02, the resulting code that comes out of the compiler is completely different. You wouldn't really recognize it if you put them side by side. You really have to puzzle between yeah, the source code and the -01 code, the -02 code. So compilers are very sensitive to the particular configuration, and you have to make sure that you are with your certification, your pre-certified compiler, that you are using the right configuration. Libraries are a bit less sensitive, and I don't know the details of DO178, but in the automotive industry, for the library, it is sufficient to qualify the source code. So the library source code is what you certify. And yeah, if you have a good compiler, then it doesn't matter whether you compile that to processor 1 or processor 2. You can rely on the compiler being certified that you do that compilation in the right way. I can imagine in the aviation industry that is a bit more strict. Am I right, Vance?
It is. It's a little bit different. Yeah. Yeah, it's kind of fun. It's a longer answer, but Marcel really nailed it. The compiler settings. Yeah, you can optimize a compiler. You can optimize it for speed. You can optimize it for size, right? Can't have both. You can have a Ferrari or, yeah, a Prius. You can't have both. So, folks, you have to, yeah, certify to the exact compiler settings you're using. If you change the compiler settings in aviation, unless you're level D, David, you're the, yeah, cockpit recorder, mission software, etc., then yeah, you don't get a free pass. It's not only the source code. We have to show, yeah, on the target hardware for level A and B, or source binary correlation, yeah, for level A, okay? But the key is to just use one set of compiler options always for your entire application. If you have different compiler settings, ooh, that really complicates aviation certification, because we are not source code based. We're also, except for level D, we're looking at the output. Okay, interesting. Fun topic for another webinar. But let's see, we have another question. Marcel, I think this one's going to be you. Consider a soft float implementation. If the compiler produces a function call for add to a library, it's a library. If the compiler emits the corresponding assembly directly, it is a compiler functionality. Is that correct?
Yeah, that's correct. If the library is called in a soft float implementation, there is obviously some source code in the library that's going to be executed, and that's really library functionality. If it goes to the hardware directly, if it's just one or two instructions in the hardware that are generated by the compiler, there's no library in between there, so you don't have to worry about the library there. And then it's the tool that you depend on to create the right execution. But yeah, if you go to the hardware, then obviously you rely on the hardware to be correctly implemented. So you would also have to make sure that the hardware is up to the job for that.
Fantastic. Marcel, thank you so very much, and your team, Monica, and everybody who helped all the great work. This is like putting on a wedding. It's only a brief celebration of technology, right? But somebody spent a lot of time planning that wedding. So we enjoy our marriage with Solid Sands, and hope we don't get divorced. You know how that goes. Folks, thank you very much. Marcel, any last words for our folks before we tell them goodbye?
Well, thank you, Vance. Yeah, people know where to find us, and it's always great fun to work with you. So I'm getting a bit rosy here by your words. So let's say goodbye
Awesome.
now. Thank you all.
Bye, folks. Thank you.